Thanks. Hi everyone. So I have a bit of a cold, not to warn the first lines, but if I start to mumble or drift off, help me back to my story. I'll take you on a journey of the Windows automation I've been working on since I started here. My name is Jorrit Salverda. I work here as technical architect, and what I do is automation, and more automation. The customers of our websites are not my customers. My fellow developers and operations engineers are actually my customers. Because I want to make sure that people don't waste their time on repetitive manual stuff if we can automate it away. And at the same time make sure that people trying to launch new applications don't depend on other people helping them to servers, etc. Like we heard, waiting for 3 months, we wouldn't want to have that happen. So I have one question to the crowd and a raise of hands. Who has done any Windows automation in the past? Okay, so that's a couple. Anyone who built Docker files or containers? And anyone who is running them in production? Docker? Okay, so one of our brands, like Stephen said earlier, is Cheap Tickets now, and you'll might be familiar with it. When I started here, everything ran from Windows, and luckily, since a year, the whole front end is all Dockerized and running in Kubernetes for production. But we still have a really big stack of Windows applications that make our money. So, and before they'll be replaced and Dockerized, etc., will be at least 1 or 2 years further. So, how can we take the pain out of managing all those Windows machines? For that, we need to go back when I started. This was what we saw most often. All the machines we had running, they were running for a long time. And actually, no one actually knew what went into those machines to configure them to run the software we wrote ourselves. So my first task was to find out how actually to replicate the configuration that went into those machines to be able to create a new machine to run the same software, because that was nowhere to be found. So that took a bit to reverse engineer everything we needed, and at some time I had a big set of scripts that could actually do this. And for our staging environment, we could run this to spin up a whole environment that ran all of our applications in a single box. But the process was so brittle that people actually not bothered to recreate their environment regularly, and when they did new stuff, they manually tweaked the servers, and knowledge got lost again, and then later on we had to reverse engineer again what people did. So half a year ago I saw that Spinnaker was launched as the deployment tool from Netflix, and what Netflix does is bake a full VM image for every single release they do. So I thought, well, that might sound a bit daunting for Windows to recreate the whole VM every time we do a new release. But let's see if we can automate it and how that will work. Let's step back a bit, the reasons why we want this immutable infrastructure. We also run a lot of machines where we do config management, but then we change the configuration and we apply it to the existing fleet. But no one ever tests whether it would work when we throw away the machines and try to run it from scratch. Baking VM images from configuration from scratch ensures us that we can do it from scratch, because we do it for every release and every new build. Then machines that have been running for a while, who knows who touched it and what they changed on that particular machine to get their application to work well. One machine might differ from the other if you do things manually and you you don't have your configuration management specified into so much detail that it will correct those manual changes. Doing it for every release, creating a new set of servers, ensures that people have to script it, because otherwise they release their next version and all their manual changes are gone. So that's a good thing. And although I automated all the stuff that went into building a new server, still the system how we deployed our software there was very brittle. We still have it for a couple of development environments, and people can't fix it autonomously. They still come to my desk and ask me to help them out if it's broken again. And that's my bad, because it's such a brittle system that it breaks often. So that's one of the things I wanted to fix as well, and that's a very selfish reason, because I don't want to spend my time on the old stuff, but on new stuff. And then some side effects are fast recovery after disaster, and to have an audit trail of the exact configuration that went into all of your machines. The audit trail, I'll come to you in a minute. The audit trail is very important, because we're going through a PCI audit trajectory to make sure we can handle a credit card numbers, and one of the most important things they are after is process and an audit trail to see exactly who did the deploy at what time, who changed this configuration in the machine, etc. And rebuilding the machine on every release from version control, essentially, gives us that audit trail as a side effect.
Yeah, one I would like to add to that is related to the first one, but security. In general, if you have a security incident, you can really quickly recover.
Yeah, so that's why PCI is interested in as well. Security, security, security. And with this approach, actually, outside of the development machines, no one really has to log into any VM anymore, because we know what went into it, and we know which configuration is there, etc. And with the existing machines we did deployments to, we had to spend time investigating why things were broken, and then after half a day of investigation it turned out that one setting was different from the next machine, and we wasted a lot of time where we, in the new situation, we could just kill the machine and replace it with the next one. So we listed some goals for this automation I tried to achieve. So the important thing here, scripted VM images from 0 to running our application. Every deployment had to have a new VM. Well, maybe not one of the goals, but the way we implemented it on Google Cloud with an instance group force you to have a baked VM to run and auto scale. But then, as a nice side effect, it forces people to script all their changes to get their application to work. Our previous staging environment didn't have zero downtime deployments, where production did. So that was one of the goals, because practically all of the development in Travix depends on having this staging environment operational, and every time we did a deployment it wasn't available for minutes. And that puts a brake on a lot of people's work. And the auto scaling, that's a nice thing on the Google Cloud we could do. And then some bonus stuff I worked on was making sure we create our certificates automatically, all the TLS certificates. So we use Let's Encrypt for creating production-worthy certificates. They're valid for 90 days, so you're kind of, how do you call it? Well, they enforce you to automate it, because or you spend time on it every 90 days. But, so in our deployment pipelines, we do auto renewal of the certificates if they're older than 60 days. And you could bump that up at some time where you replace your certificates every 10 days or so. And we set our DNS records as well, and the whole reason to do this is so that every development team can create the whole infrastructure they need from their deployment pipeline. So to get there, from treating our servers as pets, we know all the IP addresses of our dear beloved friends in the data center. We actually want to get here where we treat our service as something discardable, and we don't mind killing off every couple of hours or days. So I said I was inspired by Spinnaker baking images, but how could I do that in a similar way as Docker does for us? So what Docker does brilliantly is combine a couple of things in one file. The top, let me see if I can get it to work. Yeah. The from keyword tells us, hey, there's already a base image, and I want to base this new image from that particular image. That makes a layered approach to your to all your application containers possible. Then the run is what happens during the bake time, so to speak. The stuff that goes into your image by executing the run stays in that image forever once you've uploaded to a registry, and then you can reuse that same one, and you know exactly which files are in there. And well, Docker can tell us which ports to listen on. They can copy files into the image, so you would put your own build artifacts in there. And then the entry point script is what happens on runtime. So the rationale behind Docker is to build once and to run it many times. And I wanted to make sure that we could do the same thing with our Windows. Build it once, use the same image for our staging environment, dev environment, production environment. So we're sure that what we are actually testing on one environment doesn't suddenly break on other environments because of subtle changes. It can still break because your configuration is different, but that's a kind of chicken of egg in continuous delivery. How do you test your production configuration before you actually hit production? So what I use is Packer. Packer is really good at baking VM images, whether it's Linux-based or Windows-based. They take the pain out of starting VMs and at the end tearing down the VM and baking an image, and they do that for Google Cloud, for Amazon, but also for KMU, which your own hypervisor can run. So they support all kinds of images you can then run either in the cloud or on-premise. To have the same kind of concepts as in Docker, it was hard to get it into the same file, so I split it into a couple of separate ones. So we don't have a from keyword, but my pipelines that build the images depend on other pipelines that bake a lower level image, so to speak. The Packer file is what's used during build time or bake time. And then the entry point is what's used to run it for different environments and to configure it correctly at that time. In Docker, you can pass in configuration through environment variables. Google Cloud and Amazon, they use metadata to get configuration values into your VMs. So we use that. And in our entry point file, we actually query the metadata to configure things. And then the copying can be done in different ways. On one side, we let the Packer library upload our artifacts into the VM. And on the other side, we download external dependencies. So it relies heavily on Chocolatey, which is kind of a package manager on top of Windows. And then you have some more exotic stuff in Docker, mounting a volume, and then exposed to list ports. I haven't done that much work to make it a similar process for different applications. So some of our stateful applications do mount a second drive, and we format it and store our data there. And the applications so far all listen on port 80 to make it simpler. So an example what the bake time file looks like, the packer file. It's just a couple of PowerShell commands. Since this from the Chocolatey package manager, it installs .NET 4.6.1, fetches it from online. Someone took the effort to put in the parameters how to install it unattended, which is pretty tough with Windows. And then we created a set of our own functions we use to either stop or start functions or do other modifications, create directories, etc. And then at the runtime,
how do you start your application?
Well, I don't have an example here, but maybe later, if we have some time, I can show how it's copied into the VM, and we then put it in the right location. So this is, for example, some stuff that goes into our lowest level base image, because it's Windows, we're not going to run anything else than .NET on there, so we want to make sure the .NET framework's in there. And we don't, for sure, want Windows updates while it's running production. We make sure Windows updates are in there at bake time, and they don't have to do that during runtime. And then so here the entry point that does things at the runtime. We still have some process where we bring in a lot of configuration as a big XML chunk and then do replacements in config files. That's what happens in this function. And the XML is set as metadata, so it goes in, or is available to us. And can be different for different environments. And then at the end we start all of our applications that are installed on that machine. So we use GoCD for a lot of our build and deploy pipelines, and the contrast is a bit bad, but this shows you how our different images depend on each other. So we have the base image, like the .NET framework went into that. Web server installs all the IAS components we need for us to be able to run an application. This is actually the pipeline that builds one of those .NET applications, and then the artifact goes into the bake process for that particular application, that specific revision, and then we can deploy it to different environments. So here again we have a layered approach where we can save ourselves time on the per revision bake process by doing stuff at a lower level that gets reused. So we don't have to install IAS and .NET framework every time, because then our bake process would take a really long time. So this is the power to the development team. Everything that's needed to spin up their infrastructure, whether it's an existing application or a new one, is in this pipeline. So it tells us which Google Cloud zones it gets deployed to, what machine type. If we see that we're running out of memory, next deploy we bump up the size of the machine. And then the next release we have the bigger machine.
Do you give like a choice? Instance types? So that they don't multiply, like the big ones?
I mean, we don't have any GUI or validation on top of this, so no. But but so far I'm still the one filling in this stuff, and I hope at some time that people will do it. But at least it saves myself a lot of time. But I'll get to that later. We still need to improve some things. So for the auto scaling, makes a min and max instances, and what, well, this is not a percentage, but what fraction of CPU to scale out, what records we create for DNS, and in Couchbase, what kind of buckets we need created for this particular application. So this takes out the middleman that needs to set up servers, and brings the people that do that work into an advisory role. Hey, I see your application is actually using less memory than that instance size. Can we scale it down a notch to save ourselves money? And I think that's a much better position, because if we want people doing the same thing and clicking stuff over and over, it sounds like factory work. And we want to use people's brains instead.
Is this part of the, very stupid question, part of the normal repository of the My Account application in this case? Or is it a separate repository?
No, so this is still separate. I'm trying to figure out if we can move part of the, well, this stuff, they all have access to it, and they can be, for particular applications, new applications that don't have too much dependency on shared data, let's put it like that. The teams have autonomy to deploy to production whenever they feel comfortable that their application will work. And the bake process, I still want to figure out if we can move that Packer file and entry point into their particular application repository.
Then how do you connect? So this could be different repository. Yeah, it is a different repository. Then how do you combine it then with the artifact out of your CI?
There's a set of scripts that deal with it.
They just combine it.
And there are some extra parameters and environment variables I don't show here, but they list the name of the artifact. And then that gets reused and unzipped to the right location.
Yeah, okay. Okay, so this one is more or less controlling what gets deployed.
Yeah, so this is less about the bake process, more about the infrastructure.
Yeah.
Do you create your own AMI for within Amazon?
Yeah, so we don't use Amazon for this, but you could do that. If you do that, you need to do it for every region you want to deploy to. So the Spinnaker does that stuff in parallel. You can let Packer do that, do multiple builds in parallel. The unfortunate thing is actually that we do have to run two bake processes in parallel, because the Google Cloud projects, and we separate environments in separate projects, they don't. They can't share their VM images yet. According to someone at Google, they can, but I didn't manage to get it to work. So we make it twice at the same time, but exactly the same stuff goes in there.
Sorry, maybe stupid question again. You said everybody's able to control these parameters. Right?
Yes.
I'm a very enthusiastic developer. I would put the min instances to 10. Who's controlling the amount of resources?
Google is by setting quotas we can't surpass.
Okay. So
no, but there's no. That's one of the things of autonomy, right?
Yeah.
Let people deal with it themselves. And we need to make sure, as a tools team, to give teams the monitoring, the overview of what their application actually costs to run, to steer them in the right direction. And if we agree that they are costing a lot of money and we don't care, then why should they spend time on optimizing it when they can do new features? So it's a balance. But this automation is just running for 2 months or so, and we have to find out how it's going to work. And by all means, we want to get rid of Windows at some time, but then the same issue would all happen in.
No, so I can imagine that this is also, you need to control your costs as well.
Yeah.
Yeah.
But so far, a lot of developers are really scared to even touch the button, so we still have to nudge them to control this stuff themselves.
Is it looking to desired state configuration?
Not really, mostly because I already have experience with the box starter stuff. And I think it's really valuable because it might take the pain out of a couple of things that have been very hard to do with Windows so far. Because on Windows, installing things remotely is absolutely not the same as logging into a box and installing it. Because apparently a lot of installers depend on a GUI to be present. And the box starter helps with a lot of that stuff. They do some weird tricks where they actually not run the installer directly, but create a scheduled job that then has more rights than the remote Windows or WinRM actually. So what did we learn? Windows automation is really hard and it fails in unexpected and weird ways. But now that we're doing it on every single code change, it turns out to be quite reliable actually. It still fails every now and then, but I think that's more the Packer communication with Google Cloud that goes wrong sometimes than a installation that worked before and suddenly dies the next time. But it's good because Chocolatey doesn't host any of the installers themselves. They just point to the location where Microsoft makes it available or 7-zip makes their stuff available. And the same as with Docker, it's really important to pin the versions of software you're using. Quite recently, the box starter was updated or had a new version. I installed it and things broke. And then I went back to the previous version and things were still broken. And it turned out to depend on other packages, but didn't care about their version, and they were all bumped to the new version. And it took me a while to find that out, why things were broken. So specifying the exact version for all your dependencies is really useful, because otherwise you'll spend a lot of time finding out why your build that worked fine momentarily or something fails. We don't see that only with our Windows automation, but for all the applications. So you might spend a bit more time updating your dependencies, but at least in the control manner. It's the first time we're suddenly creating new servers all the time, so our IP address has changed, and we integrate with some parties that want us to whitelist stuff, and that's then suddenly really hard, right? So there we did some tricks to give him IP addresses from a pool of static IPs. Google's HTTP load balancer, that was very interesting. One of the things you can do in HTTP 1.1 is to send the expect 100 continue header, and then Google says, oh, sorry, bad request, workaround, where it should actually tell us whether it supports it or not. So that forced us to change a lot of our software to cope with that. Part of our stack is running on-premise, and then new stuff is running in Google Cloud. How do we let those two communicate with each other, again, if the IP addresses change all the time and we can't whitelist stuff, but we don't want to open it up to the world yet. Unfortunately, we don't have OAuth between all of our inter-service communication. So one trick here was to put client-side certificate in place that we sign ourselves, and then it tells us, hey, that's our application that tries to connect it. Yeah, you're free to connect. And all the other and then training. I think we spoke in the previous presentation about adoption and having to make sure that people get on board. It could still be, hey, if something breaks, we run after Jorrit and he helps us, but I want to make sure that people do it on their own and make sure they can change those Packer files themselves, etc. so training is needed to give people hands-on experience, and they don't fear the new stuff anymore.
So this is training for the users of the
For the developers,
automation
no,
platform,
yes.
not for the people implementing.
No, no. So it's really for the developers to understand what's happening. What's next? Well, it's still a all or nothing rollout, and the Windows startup times are a bit disappointing. So it takes us about 5 minutes to deploy a new version. Could be 100 VMs at once. That's nice, but it still takes 5 minutes. So what if this release breaks things? It takes us another 5 minutes to roll back to the previous version, which is far too long. If we're doing millions of requests per hour, it will cost us a lot of money. So what would help there is to do automated rollbacks. Have the deployment look at our error logs. If the error rate goes up for the particular application, automatically keep the old version standby, automatically roll back to the previous version. Monitoring needs to be improved, so the teams themselves can be very confident that if they release it, they have all the information that tells them whether it breaks things in production or not. And then speed, because the bake process takes about 6 minutes, the deployment about 5 minutes. If you're doing other stuff, it's fine. It's done before you actually have the time to look at it. But if you're waiting for it because you try to get that fix out, then those 10, 12 minutes are really gone. And then we hope that this will support our end of life of Windows, this strategy. And then in a year or two, no more Windows, hopefully. Or just a small part that will be supported by this. What do I help here? And people were talking about, are you going to do legacy systems as well? So this is all for our legacy. But do we need to improve the speed so much that people are actually happily using this? Or do we leave it as is, have a fairly slow release schedule, and show them the path to the new way that's really fast? For comparison, we're already building .NET Core applications. You can make Docker images from it, you can run them in Kubernetes. We do that, and their deploy times are about 20 seconds. So it doesn't compare. And even with all the effort we can put into Windows improvements for boot times, we won't get to the 20 seconds. And it's not only important for when a person hits the deploy button, but also for auto scaling. What if the load rises and we need to wait for 5 minutes for one extra VM? Then you need to, nano server, but nano server doesn't support the old .NET framework, but .NET Core, but we can make a Docker container from .NET Core, so why would we do that? I think that's it. We had a lot of questions already, but probably a couple of them.
You said you disable Windows Update, so how do you, what do you use as a base image? Because that base image contain all the latest updates?
Yeah, so Google refreshes their base image for Windows 2012 in a regular interval. We use the latest then. I'm still working on getting the Windows update and that base image applied, and probably in the web server image as well, because we install IIS and it probably has tons of updates. But that's one of the things that's really hard with Windows remoting to get right. You would think it's their own stuff, they made sure it can be applied remote, but it's unfortunately not like that. So that's something that needs to go in there. Very important for the PCI audit again. Do you have the latest updates in there?
How does the database fit this whole story?
So
it's not immutable.
No, so I did make an image to run the database, but it can easily run as long as the other one you saw at the beginning, because that was actually a database server. And that's tricky, right? Because probably the most vulnerable part of your infrastructure is where the data resides, and that's the one you replace the least amount of time.
But how do you upgrade the database schema and also support automatic rollback?
Okay, so what works there is to do like Facebook does that. It's called expand and contract. So they only do database changes once a week, and they're decoupled from software updates, which they do every day of the week. On a Tuesday, they add new fields to the database. Then the software that's deployed, or the database changes work for the existing software in production. The new software can use those new fields, might need to do migration of data from one field to the other. And then you have to have a good administration that tells us, hey, once everything's over on this new version that supports it, and we no longer use that old field, and we can remove it. But the important part is to decouple it from your application deployment.
What do you use?
It differs per team, but what do we use again? In back office,
one of the simple things we did, we just said, for instance, in the platform we still use scripts, just change scripts. But the simplest thing you can do to support continuous delivery is just say every change has to be that previous version. And if you have that as a rule, that basically means that deletes on columns or tables, you have to do it, you can't do it immediately. You have to wait one version. And that helps a lot. It's a simple rule which really makes it a lot simpler to do.
Yeah. And one thing that works well if you have a relatively simple setup for your database is the Microsoft Visual Studio database project type. It contains your full schema, and it calculates, compares it to a target database, what changes it needs to do to update it to that schema. And I did all that work, and it worked fine on our staging. But then on production where we do replication, it turned out Microsoft's tooling doesn't work with one of their own features, namely replication. So we're still a bit in limbo there, but we're going to replace SQL Server as much as possible by a distributed type of data storage. Have a look at our GitHub account. A lot of our Docker files and base files are open source there. I still have to see if I can release any of this Windows automation work. That would be nice. Because a lot of time went in there, and it's actually good if other people that have the same kind of issues could do similar automation.
So in Docker you have like incremental images. For release you can, Docker can say these files have changed, so you need to update just these files for this version. Can you do that in Windows too?
Not really. So we this concept lives by the what do you call it? The happy thing that Google's cloud is really fast, at least the network, super fast. So we're actually baking for a 20 MB release. We're baking a 6 GB image with everything from Windows in there. But it still happens in those 6 minutes, right? So we don't really care. The data is really cheap to store. So every single line of code change builds a new 6 GB image. So cleaning up your old stuff is important. After a couple of weeks, we delete those old images. So it doesn't have the concept of the layered approach, which can actually speed up fetching those changes as well. But Google does that very fast. One of the things on top of our list is to do this same stuff on premise. And we'll see if our 10 gigabit network will cope with shipping all that data. That would be interesting.
Because you're running, who will you take license from? So you pay
We pay per use. You pay a fee on top of each Windows machine.
If you run it on premise though, you have to think of licensing?
Yes, but that will go through our MSDN license, I think. You can still use your specific license, I think. You just need to make sure you pay for all those machines. That's a bit of administrative overhead. I don't know exactly how it goes. We'll find out when we start to automate it.
So, are there any technical reasons why you don't run your .NET Core applications on Linux?
We do run it on Linux. So the .NET Core stuff, that's
Yes.
the next gen .NET framework
Yes.
for everyone that doesn't know it. It runs on Windows, on Linux, on Mac, and Docker is essentially Linux. So we make a Docker image from it.
So the technical issue is that you have to migrate your code from current .NET to .NET
So
Core.
this is for new applications we're building.
Yes.
Where the .NET Core framework isn't released to manufacturer yet. They do have a license in place that you can run production with it, but it will change over the next few months. And hopefully later this year it will hit the RTM. Then we'll start to train our other teams that are still doing classic .NET development. But it's unlikely that we're going to migrate all of our existing code because the next gen .NET Core is actually a subset of existing .NET versions. So there might be stuff in there that isn't supported. But we'll definitely give it a try to convert a couple of applications. Because if it works, it's really a huge thing, and then we can speed up replacing the Windows machines and speed up deployment times and build times.
Do you already have .NET Core applications in production?
Yeah, it's running production, certainly.
What's the experience?
It's super fast. The nice thing is that on classic IIS or ASP.NET applications, they load tons of middleware to do all kinds of stuff you might not be interested in. So one of the things is that every ASP.NET application can serve static files, even if you're building a web API that shouldn't serve static files. So the .NET Core for the web is totally different, and it's just like the nano server someone mentioned. Start from zero and just add exactly what you need and nothing more. And that's the opposite direction that they used to come from. So far it's fast and reliable, but it doesn't get the same kind of load and CPU intensive work as some of our other applications yet. So that will still have to prove itself at some time. So, but I think at Travix we don't fear doing new stuff, especially if it helps us to accelerate. But it should also be fun to build software right and to find out new stuff. So that's mostly up to people themselves. If they think it's a good idea to do new stuff, then by all means do, as long as they make their deliverables in time. Yes.
How much do you hate Azure?
Pretty good. Sorry. To be one
It
of
seems
the-
like the most obvious choice for your challenges.
Yes. The disk I/O on Azure is really to weep. It's so incredibly poor. So the full Windows machine takes over here 5 minutes to boot, which is still a long time. But actually the first part's done in a minute or so. Google has provisioned the machine and it's booting. And it boots faster on Azure. I've copied files on the same disk on Azure that only did 300 kilobytes per second. That's
We started off in Azure.
nothing to it. Yeah, so the original development environment that had all the applications in one box, it ran on Azure, and now we have one machine per application, so each machine just runs its own stuff and nothing else. And the pricing is comparable, even though we run 35 servers instead of one beefy one. So by all means, I think the Google Cloud's a very valid candidate for your .NET stuff. The big thing missing there is they don't have hosted SQL. And have base images that run SQL Server and just pay for your license per use. That's something that Amazon does and Azure does as well. So I hope that Google will catch up there. But probably will be off of MS SQL before that time. I hope so. But I mean, one thing, it's not Microsoft bashing. The Windows stuff is hard, but the new .NET Core framework is beautiful. So they do build really great stuff there, as soon as they choose to leave legacy behind. And that's what they did in .NET Core. They still want compatibility, but not the full set, just a subset. And then do the approach to how we do the web application quite different from what it used to be. And that brings great stuff. That's really worth it. And the open sourcing of the .NET Core framework is probably one of the best things they did to make sure it gets adopted more. Cool. Well, thanks for your time.